Cities.
Sewer to Tri-Cities.
From Service District 1, which is really kind of big. You got over 11,000 ETUs coming in there. And this pumps it all and heads it off that way. Any questions before we go in first? Actually, anybody been to a sewer pump station before? Okay. Usually when you pop the wet well and look, that's when people decide they don't want to do this job.
Valve box here.
That's the wet well. I'll open that up.
That's the wet well over there.
Everything pumps up, goes around and heads off to the force main. Each valve, each pump is designated by 1, 2, and 3. Each pump has its own check valve or isolation valve, vice versa. So you can isolate the pump from the force main and work on it. Check valves are designed to keep the flow from going back into the wet well. And they have the standard Zurich plug valves on there that, in my opinion, are a waste of time because they cut down the diameter of the pipe, but they're designed for sewer closing. As they open and close, they actually clean off the head, front of the valve. This way you get a good seal every time.
You have to get a permit to do maintenance?
On these, we know. We're all permitted inside the county. So we have outdoors. This particular vault is vented, so it's really not considered a confined space because there's a proper amount of air changes going through it. Also on this vault, if you look up on the wall up here, we also shows you it's sensing itself whether there's H2S, you have a red light or green light vented. And that's the growing standard now for stuff coming out, that everything has to be considered a confined space unless it's air changes, and it needs to have the proper sensors in there to tell you if the air is good or bad to go in.
How often do you calibrate that?
That's done, I think it's done monthly. We have guys come in. We also have meters we carry on person that are calibrated every time they leave the shop.
Okay.
So you need more than one person before you go down in this?
This particular one, no.
Pig vault.
Force mains, according to your paperwork there, you can either go one way or the other. The pig vault is designed to put a big styrofoam or foam bullet in there, and you shoot that out your pressure main, and it cleans the pressure main all the way down the line and comes out the other end. It gets rid of all the grease and everything built up in the pressure main. This is just the access to doing that. You put foam in there, you charge that with water, it gets on the pressure main side and shoots off down the go. Also in the pig vault, you see they have all the electronics and stuff going to the pumps.
Are there any calculations you do when you do that, like how long it takes for the pig?
You can pretty well check if the pig is in there and you got so many gallons per minute pushing it, and your force main's so long. If it doesn't show up within your allotted time, it's stuck somewhere.
Okay.
But I know we have some pigs in there that are pretty good size, and they have a hollowed out place where you can put a sawn in there, so if it does get stuck, you got some monkey out, we're trying to find out where, which is kind of dumb because most of these force mains are, pretty deep in the ground.
Yeah.
But pigs are soft enough; they will
eventually
come through. Eventually, not today, tomorrow.
So what do? You just increase the pressure behind it, or
no? You just
wait.
It'll force its way through.
You still have picking tape? You still use picking tape?
No, we usually put a sawn inside and check it out with that.
Sawn the data log.
That's old school, right?
Yeah.
Then we can track it.
This station,
with the converts to your 1 million gallons a day right here.
Specially designed pneumatic valve that opens and closes according to the wet well level. This valve is
pneumatic valve.
This is a big rubber bladder that shuts and opens. Yes.
Big rubber bladder opens and shuts.
So this is going 24/7. If he opens up the wet well, you can see it's down inside fall. This is basically all by itself.
Pneumatic valve.
They call it a pinch valve. I don't know if that's the company work or what, but that's the thing designed it is. And it's designed that if it does fail, it fails shut. This way you don't blow by your wet well. So it needs air pressure to keep it open. You can hear it's adjusting its flow right there.
2 to 3 MGD pump station.
Also comes with its own backup generator power.
Goes with a
This
backup
right here
generator.
is the electrical room, the control room.
It's control room here.
This station is VFD. There's 3 pumps, hence there's 3 VFDs.
3 VFDs.
VFDs are controlled by the PLC. PLC is controlled by the wet well level. Wet well level is controlled by the bubbler system, which is those 2 air tanks up there. And I think I wrote down on your papers kind of break down how the bubble level system works. Everything works off a 420 milliamp signal, which that PLC justifies as the wet well level. It changes the 420 milliamp signal. It tells these VFDs which ones to turn on and which ones to turn off to keep the wet well at the site level you want it to. The reason why you use VFD stations, especially this size of a station, is to keep a known constant flow going to the plant. This way the plant doesn't get, a big slug of sewer and flow by their bar screens. They have a pretty good idea how much is coming from the station at any one given time. This right here, I told you about the pinch valve. Well, as you can see, this is how many NGDs go into the Tri-Cities right now. That's the level of the wet well, 6 feet, which is pretty well close to what it's saying there. And that's the opening of the pinch valve. So right now it's open almost 100%. With this touch screen, you can go through this touch screen, you can see, you can adjust flow diversions. You can adjust basically any setting in the station. You can adjust what pumps are running, what percentage they're running, amp feedbacks. Like if the amps are really high on this pump and they're running the same, chances are this pump's plugged. So that'll give you an indication to go pull a pump, other than your normal maintenance. There's also trends on this one. And this is like a science fiction screen here, but you got 3 pumps. That's a diversion valve, which is opening and closing all the time. This is the 3 pumps pretty steady at what they're putting out. This is enough to run the station. 2 pumps on the station, full speed. Generators are designed to run at full load for 24 hours. This will come on all by itself without any warning. I do a little buzzer before it goes off, but that's how it is. That's the transfer switch back there, the one in the corner. Yeah. The other box over there that he's standing behind is what they call it, a harmonic phase filter. And what that does, it's required by PGE now that if the VFDs have a tendency to run at a certain frequency, they put dirty power back on the grid, which messes up the guy's radio across the street. So that thing is supposed to design to clean out the wave on the back.
Yeah.
Chemical feed system here. What chemical are you feeding to keep the...
This is proprietary bioxide, which is just like a salt water.
Okay. Bioxide.
It puts nitrates in there, so the H2S forms in a non-air environment, like a sewer pipe, right? And it produces, hydrogen sulfide as a byproduct, which turns into an acid, which eats up your pipes, eats everything up. They put this chemical in there so it gives it something to eat, keep it alive, and it produces nitrates, right? Which is good and a bad thing. Too much nitrates in your sewer at the plant, you start getting filament organisms and you start getting foaming and stuff, but it doesn't. That's if you dump that whole tank in there at one time.
Right.
This is dosing relatively immediately at 38 gallons a day, which is kind of high, which is low because when they first put this in, they were thinking 80 gallons a day. So I chopped them down to 30s, and it goes according to the type of sewer flow you got going through. If you get a lot of I&I in the winter times and stuff, you can drop this down, but you got to keep sampling and sampling and sampling to keep up on it. Which is, if you have this stuff is working out at $4 a gallon. You got 4,000 gallons there. You figure the math, and you're filling this thing up every 4 or 5 months. So it's a pretty good hit of money right there. So you got to keep up on chemical dosing. Really expensive, relatively cheap compared to doing. There was a guy at short school who had that UV thing. What do you call it? Ozone.
Ozone, yeah.
And which is nice, but most ozone does its best job for odor control at discharge manhole. Most discharge manholes are in the middle of the street. You're not going to be running 110 volts out there and making a volt for ozone. You're better off just putting one of these things over here.
You say about 30 gallons a day?
Well, this thing I think is putting out 30 gallons a day right now. And it does that with just 2 little chemical pumps right here.
There's the chemical pump.
This is just pumping it in. And it's set up where you can do drawdown tests and measure your own gallons per day, but you do a drawdown test, you go into scale right here and you can figure how many gallons per day you're putting in. Relatively simple. It's a no-brainer system. But all in all, there's going to be...
Dioxide going in. Bubblers here.
Clean it, wash everything down, but we do all that from up here. We don't use the back truck or something. No, we actually get that hose right over there. It's laying on the ground. It's got a long pole.
That one over there we just put in a big pump station over by the old McFarland's junkyard, and before we put it into service, we picked the line, cleaned the line, and it came shooting out down here about 2 hours later, and then somebody had to go down about 60 feet to our main wet well retrieving station over here right before the headworks, and then go tie rope around it. We use a crane to lift it up.
Lift it up.
It was kind of cool.
Was that the plan?
Yeah, that was the plan.
How much?
That's why it's wrapped up in Visqueen there because it was hanging out in the sewer. So feel free to give it a hug.
No thanks.
This one hasn't been used. You don't pig very often, but like when you put a new force main into service, yeah, you want to give that. And I mean, usually if you're working with blockages in the sewer lines, it's a 4-inch pipe. You just use the Aquatech or whatever hydro cleaners. You just put a nozzle on it.
And these are all your water attachments,
yeah, this is like root cutting here. We got all our fins and all our nozzles. Let's see if there's a nozzle scratcher anywhere. We got little ones.
Is that the kit?
It's all for like backfiring sewer lines. Clean sewer lines. Water sprays out this way. So when you pull it back under pressure really slow, you're scouring the pipe.
Right.
Huh, cool.
So that's good for cleaning. We use these for cleaning. Use front fire ones for breaking up stoppages. They're probably all in the
So
truck.
they do have even the backfire ones do have a little bit of a front fire on them, don't they? Don't they have a little hole in the front?
Well, these ones just all spray
All
backwards.
spray backwards. Okay.
Yeah, you run it up the pipe quick.
Yeah, you let it go by just...
And under lower pressure. And then when you're ready, once you clean sewer lines, you go to a downstream manhole and go up. And then from there, once you got your footages to the next stationing, which would be your upstream manhole, then you pull it back under higher pressure slowly. So you're pulling everything
Blast
down.
the sides.
So you start at the top of the system and work your way down until you've pulled all the debris down to a pump station, pretty much.
So what's the range of pressure that is developed by, in general, what is the range of maximum operating cleaning water pressure that is developed by a hydro cleaner during a collection system cleaning from blank PSI up to blank PSI?
That's a good question. Tom will have a definite